In this lesson, it will explain theorem number 7 and theorem number 8, and then rubber approval theorem number 8, and then level the examples. So let's get started anyway. This theorem here, a tangent to the circle is perpendicular to the radius at point of contact. First, let's understand what is a tangent. Actually, a tangent is a line or touch a circle at one point. For example, any line or touch a circle at one point. In this way, this line is tangent, and then radius is any line from the center. Any line in this way, it look from center and then here at the circumference, meaning here mogodimo circle. That line ke radius. Based on this theorem, a tangent in this way. On a tangent A, B, C. This line is tangent, and then wabale a radius. A radius OB from the center. So a radius mo in contact, it touch that tangent. On angle 90 degrees. So that radius is perpendicular to the tangent, meaning a former angle 90 degrees. So in conclusion, OB is perpendicular to AC because the tangent are in. So in over straightforward. Every time I go a radius and then you touch the tangent, that radius is perpendicular to the tangent. And then morally a related practice problem. This questionnaire, given circle with center O and tangent AC, determine the unknown angle X. So morally center and then a line yellow it from center and then it touch the tangent because parfilo tangent AC. This means a radius a perpendicular to AC because parfilo radius and then tangent and then every time a radius ya touch our tangent 90 degrees. So now a right angle triangle because this angle is 90 degrees. So this question you are very easy and straightforward because now a right angle triangle. But the first thing C angle BO is equals to 90 degrees. So can you explain why angle B 90 degrees? And then for reason for this theorem tangent is perpendicular to radius. And then from here globally 72 degrees plus 90 plus x is equals to 180 degrees. And then reason key angles of triangle because that's already angles to triangle here the add the 180. And then from here 72 plus 90 key 162. And then now we'll solve for x, and then I solve for x, it will be 180 degrees minus 162 degrees, and then here for 18 degrees. So key angle x. I think this question really is really or this theorem. So the answer in this way. And then now morally a converse. Converse is like a reverse. This converse array a radius at 90 degrees lay any line. Let's say we feel this radius and then we at 90 degrees. And then only any line you touch in this way. But you're not sure this line is a tangent. So this theorem area for as long as that radius at 90 degrees to any line, e rela gore that line ke tangent, so ke reverse. So ge re šomiša this theorem re re line perpendicular to radius, and then this theorem le the previous one ga se for exam purpose, so in exam you will never prove that theorem. Wena o tlo no tshwana gore o itsebe and then o tsebe le o e šomiša, so e no ba straightforward. And then this one re two tangents drawn from the same point outside the circle are equal in length. Mo re na le tangent AB and then ra ba le tangent CB, but the key thing gore o ka kgona go bona gore these tangents are di drawile from the same point, this point ya B. According to this theorem e rela gore this tangent and this tangent di a lekana, so e no ba in this way. For as long as o ka ba le di-tangents tse two tse e le gore o di drawile from the same point, e rela gore those tangents di a lekana. And then ge o e fa a reason o šomiša this theorem, o ka ngwala in this way, wa re turns from common point. And then it's important gore o tsebe gore this theorem in your exam ba ka re o e prove, so it's for exam purpose. Therefore re tlo tshwanela gore prove this theorem, re tlo prove gore AB e lekana le CB. Re nyaka go bona gore ka nnete di-tangents tša rena tše e le gore di tšwa from a common point di a lekana, so re tlo prove this theorem. And then now mo re nyaka go prove this theorem, the first thing rile a given circle with center O, tangents AB and BC. O ka kgona go bona gore na le center ya O and then ra ba le tangent ya BC and then ra ba le another tangent ya AB. Ge re tlo prove this theorem, the first thing re tlo dira construction. Ke tlo constructa a line ya go tloga from the circumference e ya to the center, and then ka dira the same thing. And then ke tlo constructa another line ya go tloga from this point e ya to the center, because ke nyaka go ba le di-triangles tše two. Ke thomile pele ka re construction ka re radii OC and OA, and then ka re join BO. Remember gore radii e no rela gore di-radius, ke na le radius ya OC and then le ya OA, but ke constructile. Remember radius ke any line from center to the circumference, meaning e ya mo godimo ga circle, so rela gore ke radius. This means ke na le radius ya OC and then le ya OA according to the construction. And then ka re join BO ke this one, BO. Remember always it's important gore o ngwale construction ya gago, because construction e na le a mark. So from here ke tlo šomiša congruency go prove this side and this side gore di a lekana. Remember in grade 9 and 10 go na le the congruency, re na le 4 rules ya congruency. Remember gore congruency ke ge re nyaka go prove gore di-triangle di a lekana. Di-triangles ge di le congruent ke ge di le exactly the same, di lekana. So re na le di-rules tša go prove gore triangles di congruency, but e re go fe a quick revision based on the congruency e le re go e šomiša. Re na le congruency ya right hand side hypotenuse. That rule e re ge re ka ba le di-right angle triangles tše two, let's say re na le right angle triangles tše two in this way. This rule e re the first thing re nyaka gore di-hypotenuse tša rena di lekane. Let's say this hypotenuse and this hypotenuse di a lekana. And then secondly, e go ka kgona go prove gore maside a mabedi a corresponda a lekana, o tla bo provile gore these triangles di congruent. Let's say o ka kgona go prove gore this side and this side a lekana, e rela gore o tla bo provile gore triangle ya go e congruent, because the key thing re nyaka go prove gore maside a mabedi a corresponda a lekana. This side and this side re tla ba re provile, this side and this side re tla ba re provile. So the key thing gore prove maside a mabedi a go corresponda gore a lekana. le go ka prova this side and this side gore a lekana, so o tla bo provile because o tla bo provile maside a mabedi a corresponda. Remember gore ge o provile maside a mabedi a corresponda gore a lekana, let's say o provile gore this side and this side again a lekana, e rela gore obvious this side and this side a lekana. Always go ka rona le triangles tse two wa kgona prova gore maside a mabedi a corresponda a lekana, obvious le side la mafelelo ra gore a lekana. So that is why go le important fela gore prove maside a mabedi. So re tlo shumisha congruent go prova this theorem. The first thing mo ke tlo re angle A e lekana le angle C e lekana le 90 degrees. The reason ke re angle ya rena ya C ke 90 degrees and then angle ya rena ya A ke 90 degrees is because of that theorem e be re explainer ya gore ge o ka ba le a radius and then ya toucha tangent e rela gore e create 90 degrees, e rela gore perpendicular. So e be re discuss recently. So e rela gore re na le radius ya OC and then e toucha tangent ya rena ya BC, e rela gore e create 90 degrees. So e rela gore reason e tlo re tangent is perpendicular to radius. And then now e ra gore re kgona go prove gore re na le the right angle triangles. So that is why re tlo shumisha that rule ya right hand side ge re prove congruency. Remember gore mo re na le di triangles tse two, re na le triangle ya OBC, ra ba le triangle ya OBA. Re nyaka go prove the congruency. The first thing mo nka prove gore OB e lekana le OB. The reason ke common sides. Ga o ka lebella these triangles o ka kgona bona gore OB e common, e wela mo triangle ya OBC ebile wela ka mo triangle ya OBA. So e rela gore re provile gore di hypotenuse tsa rena di a lekana because of common sides. And then another thing nka prove gore AO e lekana le OC, reason ke radii. Remember gore this line ke radius and then even this line ke radius. So because ke di radius ka moka e rela gore di a lekana, and then the reason ke radii. And therefore rela gore di triangles tsa rena di congruent because re kgona go prove gore maside a mabedi a corresponda a lekana. Re kgona go prove this side and this side, and then again re prove le side la rena la common, e rela gore provile maside a mabedi, re provile le side la OB and then la OB mo di triangle tsa rena tse pedi. And then in conclusion ke tlo re triangle OCB is congruent to triangle OAB ka rule ya right hand side hypotenuse. Because re kgona go prove gore maside a mabedi a corresponda a lekana, is obvious gore this side and this side a lekana based on everything ke be ke explain ka congruence gore ge o ka kgona go prove gore maside a mabedi a corresponda, obvious maside a o shala ra gore a lekana. So e rela gore AB lekana le BC, re provile re kgona go prove congruency, therefore provile gore AB lekana le BC re shumisitše the congruent triangles. So based on this e rela gore provile, and then ke answer ya rena in this way. Actually something very important e le gore ke nyaka go highlighta ke order ya di triangles ge o shumisha congruency. Mo ke na le triangle ya rena ya OCB le ya OAB, ke these two triangles ke no di separate. Order is very important. Lemoga something, ke rile triangle OCB is congruent to triangle OAB. Ke thomile ka this letter ya O, ka re ya C, ka re ya B, and then ka mo triangle ya go latela ka re OAB. So they are match. But lemoga something. Let's say or O C B, and then ka mo fase wa re B O A. Okay, dira in this way o tlo ba wrong. This is because letter ye nngwe le nngwe e represent the angle. Make sure your order always is important. Your let triangle B C O e rarabolola ka mo fase o tlo thoma ka that order B A O. So ke order ya congruency and similarities always e phela e le important. Ke na le a video tutorial ya congruency and the similarities mo ile ke explain everything in details. Just for in case ge le re o need some clarity, o ka no lebella those videos. And then more normally the related example practice problem. Determine the value of the unknown angle x. O ka kgona lemoga gore re na le tangent tse pedi, re na le tangent ya PQ le ya RQ, but the key thing gore these two tangents di tswa from a common point. This means PQ e lekana le QR. And then ge re na le this situation, o ka kgona lemoga gore re na le triangle ya rena in this way, mo re na le Q, and then mo re na le P, and then mo re na le R. Because PQ e lekana le PR, e rela gore na le this situation, and then mo re na le angle ya rena ya 48, and then mo re na le angle ya rena ya X. This means mo re na le angle ya rena ya X again, because re na le isosceles triangle. Remember gore ge re na le isosceles triangle, the angle tša go lebana di a lekana. Now re la go solve this problem e tlo ba very easy, but the first thing o tlo thoma ka gore PQ e lekana le QR, and then wa fa a reason turns from common point, and then from here wa re angle P e lekana le angle R, wa fa a reason angles opposite is equals to sides. Every time re shumisha isosceles triangle re fa a reason, re shumisha this one, ga re re isosceles triangle, so that one ga re allow. And then from here nka no re x plus x plus 48 degrees is equals to 180 degrees angles of triangle, because now re na le triangle ya rena ya QPR, and therefore x plus x, 2x plus 48 is equals to 180 degrees. 2x is equals to 180 degrees minus 48, because re solve for x, and then 180 minus 48 is 132 degrees, and then re tlo divide both sides ka 2 gore kgone go kry-a x. e tla re x ya rena e tlo re fa 132 divided by 2 ke 66, so ke answer ya rena in this way. Usually in your exam this problem e tla e na le those kind of questions mo e le gore o tlo tshwana gore lemoge gore o na le the isosceles triangle. So it's very important gore o tsebe di theorem kaofela, because in your exam those theorem ge di tla di o tla di tlhakane kaofela ga tsona, ba ka se go fa problem e one separately. So make sure you understand all those theorems. Anyway, ke answer ya rena in this way, and that's it for this tutorial.